All right, welcome to Live Coding Rust, where every week I get into live coding with Rust. So this week I'm going to dive into a interesting scenario here where you can use the package management system in Rust to invoke large language models. So I think everybody's talking about large language models and how cool they are, but what's interesting is you'll see people giving these really complex workflows and applications, all this, complexity around running a large language model. But because of the beauty of Rust and the cargo package management system, you don't have to do anything. You can just actually use the cargo system to invoke models. I'm going to do this with Hugging Face Candle, and I'm going to do it on an AWS GPU that's a very powerful GPU. So let's go ahead and take a look at how we would do that. So first up here, I've got Hugging Face Candle. Let's just look at what this does. So this is a minimalistic ML framework for Rust, and you can see the code is really simple, right? But the biggest thing here, and I think this is why it's so exciting, and I would say probably one of the most exciting things in all of LLMOps is that you can actually run all of these large language models by just running one line. So I don't know why more people aren't using this. It's pretty exciting. And let's go ahead and figure out, though, how to run it yourself. So you don't have to, pay someone to run large language models or sign up for some API service, etc. It's ready for you. You're good to go. So how are we going to do this? So first up here, let's take a look at the console inside of AWS. So what you would want to do, in my recommendation, would be you'd go to instances here, and you would say launch instance. At that point, you're going to want to pick, in my opinion, the base AMI. So, for example, deep learning base AMI is a great place to start because it doesn't have extra software you don't need installed. So a lot of times people will look at it in a deep learning AMI, and it has a bunch of junk installed on it that you don't need. Like if we're using Rust, we don't need Python packaging tools like Conda, for example. All I want the CUDA drivers, and I also want CUDA in, so CUD and in, to be installed, which is a optimized CUDA for neural network. So really, all I need to do then is just go to the Ubuntu deep learning base AMI here, which is this one. And then at that point, once you launch it, the instance type then is going to be critical. So what you would want to do is you would want to actually pick, in this scenario, you would want to pick the NVIDIA-based choices. And if we looked at the different choices here, we could actually look at NVIDIA, or we could say accelerated. So this would be, let's just say G5. Here we go. It would be the family type. And you can see that these actually have different choices here, but basically the G5s are the ones I would recommend, and they have NVIDIA already set. So now that we've got that, what I did is I went over to EC2 here, and we can see that I've got a machine running, and this particular machine has everything we need in it. And in fact, let me just show you, if I want to go back to EC2 here real quick, let's just see how I connect it. So I go to instances. I have one running here, which is called LLMOps, and you can see it's a G5 16XL large. And all I need to do to connect to it is just click connect and say connect using the EC2 instance connect. So I don't even have to set up SSH keys. I don't have to set up anything. I've just got access to it. So once I've done that, the only other thing you need to do is install Rust. So there's literally one command. You just say Rust up, right, and you install it. I've already got Rust installed, and we can do -- version. There we go. The other thing to do would be to clone this Hugging Face repo. So you'd want to go to code, go to local, and clone it via HTTPS. So you go here, copy it, and clone it. Once you've done that, in case I've already done that, I could just say get pull, right? Get whatever latest updates. They're actively changing this thing. And then I'm ready to go. And how would I actually run things now? Well, you can look at the instructions if we go down here, and we would want to actually basically build one of these modules. So there's two ways to actually invoke these large language models. One is to just run it, but I think a better way to invoke it would be to build it, then go to the target directory, and then play around with the model. So let's take a look at this one, for example. Bigcode is essentially a competitor to GitHub Copilot, but it's open source. So if we wanted to actually run this, how would we do this? We would just go through here and start a command like this, but we want to tweak this a little bit. So we want to say cargo build, right? Because we actually want to build a binary that we're going to play around with. We would also want to say -s features. We want to say CUD and what this would do is this would actually look at the optimized CUDA driver for neural networks. And we can actually verify this by looking at this, see use features, CUD. And if we go back here, use features, see, there we go. And what this is going to do is going to build this for us. Perfect. And so I think not enough people are using this, right? Because again, everybody's signing up for expensive services that are $20 a month, but you actually can just spin up your own instance and you can run a large language model that has, in many cases, better performance. And in fact, you don't have to send your data to anybody. And I'm showing you it's not hard. So let's go ahead and cd into the target directory. You see how it says target? Let's go to target. And now we can go into the release. So we'll go into release. So your path would look like this: home, Ubuntu, candle, target, release. And then what we would do is look at the different examples here. So depending on how many you build, and notice I have one called Bigcode. So I just type in Bigcode like that. That's it. I got a large language, pair programming assistant here. So now I would just say Bigcode -s prompts and say build a Python function that adds two numbers. Pretty crazy, huh? I can't believe more people aren't talking about this. So this again is the power of Rust, is that you can do things like this. And look, we can see it's very fast, right? And if I want to run something even faster or wrap this up in a bash script or whatever it is I need to do, I have my own pair programming assistant. So we also could tweak it, right? So we could just keep asking other questions. So I think this would be a great little command line tool. Like you could write something in bash, for example, that would invoke this or whatever. But in this case, we could say hello world Rust. Go ahead and invoke it. Right. So we've actually got some, in this case, that was Python. Here we go. Hello world Rust. There's different things that we could do to optimize this, but basically, it's pretty cool that I can use my own large language model. Now, I don't know how much we can do with this, but it is pretty cool that we can actually, experiment with our own prompts, even fine tune this model ourselves. We have total control versus sending our data to some third party, place that we don't know exactly what they're doing with the data. I could also try something more complex, like show me a Rust command line tool that uses clap and adds two numbers. I don't know if it's this smart, but let's see. I think this is a duplicate. So still some tweaking here that we can play around with, but it's a nice little kind of beginning phases, especially as these models get more and more advanced. Now let's see if we can do other things as well. So what other models can we run? So we know that there's also Falcon, which is one of the ones I'm very interested in. So let's try the same thing now with Falcon. Let's see if we can get that thing to run. And so if we go back here and I go up a couple directories, see if we can just go to history. I think is always a good way to build things. And we can just say Falcon. So now let's build Falcon, which everybody's been talking about because it's got one of the biggest parameters of all time. And let's go ahead and try this one out. Great. So now if we go and we cd into target, and we go to release, and then we go to examples, that should give us Falcon. There we go. And we can see there's a prompt. Now, what's cool about this is that I can just try something. We can just say, like, you know, what is the weather like in Spain in summer? Now, this one I have less experience with. I'm not sure if it'll even work, but again, this is how you play around with stuff, is you try it out. If it works, great. If it doesn't, you can always send a bug request or bug report to the Rust Candle library. So while that one is hanging, we can wait for it. Let's see what else we got here. We also have stable diffusion, which is kind of an interesting one to try out. Let's try that one actually as well. Oh, there we go. So it actually did work. It says the weather in Spain in summer is hot and dry. The average temperature. So, I mean, again, pretty interesting is that you have your own personal assistant here that you don't have to pay anybody. All you have to do is actually pay for the compute for EC2. And if you use spot instances, this is a great way to actually save money. So I think this is a good, kind of checkpoint here for what you can do with Rust. And again, very trivial. Just go to EC2, either launch a spot instance or launch a on-demand instance. Go ahead and clone the Hugging Face candle. Then next, you can see the history of what I did. Was I went through and I build the actual release, which creates the binary, cd into the binary, and then run it. That's it. And now you got your own personal assistant. When you're done, all you have to do is go here. Don't destroy it. I would just go here and click on it, and then just say instant state stop. Then you don't pay for it. So I think this is a really cool workflow that a lot of people that even aren't Rust experts could begin to play around with, and then later maybe build your own chatbot or whatever. And it's very trivial using the EC2 G5 instances plus Hugging Face Candle.